would you be able to tell me a little bit about LRO and its role in this flight?
All right. This LRO is the primary payload, and it's got 7 instruments on board that are going to take a variety of different measurements of the moon and really provide us with a complete data set that we haven't had before. During the Apollo era, we put a lot of things around in orbit around the equator of the moon. This mission will be going into polar orbit and providing comprehensive mapping of the entire moon using a laser altimeter to get the elevation, the heights of the different crater rims much more accurately than we currently have. A high-resolution camera as well as a broad camera that in several different colors to give us maps of the entire surface. We're going to be observing at different times of the year in order to get an understanding of how the lighting changes on the moon over the course of a year. Because one of the questions is, are there areas that get continuous light so that we can get solar power at those locations? The moon turns very slowly. A night on the moon is about 15 days long, 15 Earth days long. So if you're on the surface of the moon for scientific purposes or with an outpost, you're in one of those locations where you've got 15 days of darkness. You have to either have some sort of power source like a very large battery or something like that if you're going to rely on solar power. There are a few locations that have that stick up high enough that they get light almost all the time. We can put solar panels there and not have to worry about running out of electricity. And there's a variety of other things we're interested in. There's evidence that there may be water ice frozen in some of the very cold craters near the poles of the moon. We're investigating that. And we're trying to better understand the radiation environment of the moon as well.
Well, thank you. I appreciate taking the time to talk to us today.
Certainly.